this part, we'll talk about logical operators. Logical operators permit us to join multiple Boolean expressions. Any expression that is true or false allows us to make this decision using the logical and, logical or, and logical not. Logical operators allow us to make inclusions or exclusions of quantity or these Boolean expressions through intervals. We use the power of the truth tables, as you can see right here, in order to make a decision between two Boolean expressions. Notice that logical and, both conditions must be true in order to get the true value. If one condition is false, then the remaining conjunction will be false, rather than in logical or. If at least one condition is true, then the entire expression is true. In logical on is usually flipping the value of x or the value of the expression to its opposite. For example, if it's true, not true is false, and false, not false is true. In our example of the temperature, we're going to conjunct, we're going to join the values of the temperature by making this interval. For example, if the temperature is between 80 degrees and 110 degrees inclusive, then we should wear shorts and t-shirt. If it's not true, then we need to check if the temperature is within the interval of 30 degrees and 110 degrees inclusion to wear jeans and jacket. But if both conditions are not true, then we can just simply go do not go outside, reflecting that it's an extreme temperature. Let's code this in Java. For the next variation, we're going to take advantage of our previous code where we have hot and cold temperatures. We're going to use the power of the logical operators, which allows us to make conjunctions and disjunctions. For the logical and, remember that both conditions, Boolean expressions, have to be true in order to generate a true result based on the truth tables. The truth tables allows us to make relationships between two or more Boolean expressions. If you want to make a conjunction, which means joined, you should use logical and. If you just want to make a disjunction, which is exclusion, you should use logical or. You can make a couple of variations of these logical operations by playing by the logic of these expressions, often called the Morgan's law. Use the Morgan's law to simplify these expressions to represent a problem in logical terms. We're going to use an interval to accommodate temperature. If you remember our algorithm, here we need to make sure the temperature, which is the information we get from the computer user, to be within the interval of 80 and 110 degrees in order to print wear shorts and t-shirt. But if that is not the case, then we need to check if the temperature is within the interval of 30 and 110 degrees in order to print wear jeans and jacket. But if both interval conditions are not true, then we can safely express do not go outside. So how can we conjunct this? We can simplify by using the logical and. Here we can include if the temperature should be greater than or equal to 80 and make sure the temperature is less than or equal to 10 in order to display wear shorts and t-shirt. We still have to check if the temperature is greater than 30 and less than 80. Be careful. At this point, if you want to include 30 in order to wear pants and jacket, that is fine. If you remember our algorithm, indeed suggests you have to include the 30 degrees to wear that jacket. I'm just making a point here because often this is a logical error. If that is the case, we can just print wear pants and jacket. At this point, we can safely say else. Do not go outside. The rest, we don't really need it. We simplify our code tremendously by using the power of logical operators. Let's save, compile, and run this program. Let's try a case when the temperature is 100 degrees. Notice that 100 degrees is greater than and equal to 80, and 100 degrees is less than or equal to 110. Both conditions are true. If you remember this truth table, both conditions must be true in order to make a true execution. Therefore, we're going to wear shorts and t-shirt. But if one condition is not true, for example, the temperature of 24 degrees. 24 degrees is not greater than or equal to 80. As a matter of fact, that is false. And if you remember the truth tables, false and something, we don't care, is going to be false. So at this point, we already know that the if statement will not be executed. But also the else if. 24 degrees is not greater than or equal to 30. So this is false. False and something else is going to be false. That's where we arrive to the else statement. Do not go outside. You can play with the rest of the combinations on your own.